So in this video, I'm going to go ahead and go through all the review questions that we hadn't hit yet, just to make sure you've got that to get yourself studied for the test that is going to be next week. So we're going to look at this first one here, number 2, and it looks like we've got a multiple chain rule going on there. I'm going to go ahead and rewrite it. F of x equals cosine of 4x to the 5th. So it looks like you have the inner function cosine 4x, and then you have another inner function of 4x. So it's more like the peanut butter M&M or the lollipop with the wrapper on it, the Tootsie Pop with the wrapper on it. So I'm going to start with my u. U equals cosine of 4x, and then the 4x is an inside function, so I'm going to call that w. So w equals 4x, which means that w prime equals 4. I'm going to keep linking back. So u prime, or no, not yet. U equals cosine of w, which means that u prime equals cosine, or not cosine. Derivative of cosine would be negative sine of w times the inside function, which is 4. And then I'm going to squish it in there. I'm going to substitute back in negative 4 sine of 4x. Now I got to link that back to what we had over here in the original. So f of x equals u to the 5th. The derivative of that is 5u to the 4th times the derivative of the inside, which was this mess over here, negative 4 sine of 4x. And then we're going to substitute back in the u. At the same time, I'm going to multiply 5 and negative 4 together, which gives me negative 20. The u is cosine to the 4th of 4x, sine to the sine of 4x. All right, the next one that wasn't in any other video was number 5. And I need to find both the first and second derivative. And then the second derivative, we don't have to simplify once we've plugged in dy dx. So it looks like in this first one here, I do have a good old product rule going on. So I've got the x, I've got the y. So the derivative of x squared would be 2x dx dx. We have to do implicit since x's and y's are mixed together, but the dx is just 1, so I get rid of it. And then plus the derivative of the red is dx or 1 dx. So I'm going to get rid of the dx. Keep the green the way it is, so y, and it's a plus sign. And then the derivative, or keep the x, and the derivative of the green is dy dx. And then the derivative of y squared is 2y dy dx, and the derivative of 3 is 0. I'm going to put the 2x and the 1y on the other side, so I get x dy dx plus 2y dy dx equals negative 2x minus y. Take out a greatest common factor of dy dx. We've got x plus 2y equals negative 2x minus y. We're going to take this and divide it to the other side. So negative 2x minus y over x plus 2y. Now that's the first part. The second part is I have to take the second derivative. So now I have a quotient rule going on. So it looks like my red is the numerator, my green is the denominator. So let's try it. Hopefully it comes out in the same order as that did there. So d squared y over dx squared equals. So the derivative of my red, which would be negative 2 dx dx, which I'm just going to get rid of the dx dx, minus 1 dy dx. And then keep the green the way it is. So x plus 2y. Then I put a minus sign this time. And then I keep the red the way it is, which is negative 2x minus y. And then I take the derivative of the green, which would be 1 dx dx. I'm just going to actually keep it as a 1. And then the derivative of 2y would be 2 dy dx. And this is all over the green squared. And then what I'm going to do is I'm going to take this dy dx that I had before. So this looks like a crazy mess. I'm going to plug it in anytime I see dy dx. So this equals -2 minus -2x minus y over x plus 2y times x plus 2y minus -2x minus y times 1 plus 2 times -2x minus y over x plus 2y all over x plus 2y squared. Please do not simplify it. All right, let's keep going. Let's look at, so number 8 is the next one. This is actually a really good one. There's actually 2 of these type in here. So it's saying that they want us to find, suppose that h of x equals that. We're supposed to find h prime of 14. So it looks like I definitely have a chain rule going on. So we have that h prime of x equals, actually not yet, I want to do the chain rule piece, huh? So u equals g of x. So u prime equals g prime of x. So I'm going to replace the h of x actually with f of u. So its derivative would actually be f prime of u times the derivative of the inside, which is g prime of x. I'm going to substitute the u back in to be f prime of g of x times g prime of x. Didn't really need those extra parentheses. Now we're going to plop a 14 in there. So f prime of g of 14 times g prime of 14. All right, so g of 14 equals 2. So I get to substitute in a 2. And then g prime of 14 equals 5. And then I need f prime of 2, which equals 12. And then 12 times 5 equals 60. All right, so we've got a big one here that talks about, they give us a table, f and g, and their derivatives have the following values at x equals -1 and 0. Evaluate the first derivative of each of the following. F of x and g of x are given at a given value of x. So the first one says that we have to do g of f of x at x equals 1. So this is very similar actually to the one we just did in the video, huh? So it looks like we've got a chain rule. So u is going to be f of x. U prime is going to be f prime of x. So actually when I go to take this derivative, we're going to start it out as g of u. So it would be g prime of u times the derivative of the inside, which is f prime of x. And then I substitute the u back in. So it's g prime of f of x times f prime of x. And then I'm going to plug in my -1. So I get g prime of f of -1 times f prime of -1. Ooh, I don't know what happened. Let's go back to calculus here. All right, so now I'm going to go to my chart. Okay, so I need to find f of -1 and f prime of -1. So f of -1 is 0, f prime of -1 is 2. Be careful, they're not next to each other. So we've got g prime of 0 times negative, was it -2 or 2? 2. 0 and 2. So just 2, let's see. All right, and now I need g prime of 0. So g prime of 0 is 4. So I get 4 times 2, which equals 8. All right, this one is going the other direction. So I'm getting the u this time. Ooh, here. The u this time is g of x. So u prime equals g prime of x. And then when I substitute in, I'm going to get f of u. And then I take its derivative, f prime of u, times the derivative of the inside is g prime of x. I'm going to plug my u back in. So f prime of g of x times g prime of x. And I'm going to go ahead and plug my value in. It looks like this time I'm plugging in a -1. So g of -1 times g prime of -1. So we need g of -1. I'm going to go up to my table. So g of -1 is -1, and the prime would be 1. So -1 and 1. Okay, and now I need f prime of -1. F prime of -1 is 2. So 2 times 1 is going to be 2. All right, now we're going to do, we're going to find the derivative of g of x plus f of x. So again, I do have a chain rule going on. It looks a little bit different this time. I'm going to do my workup over here. So u equals x plus f of x. So u prime equals 1 plus f prime of x. I'm going to do my, my substitution, which would be g of u. So g prime of times u is the derivative, or of u is the derivative, times the inside function 1 plus f prime of x. And then we're going to substitute in x plus f of x times 1 plus f prime of x. And now we're going to plug that 0 in. We're just following the rules every time. So 0 plus f of 0 times 1 plus f prime of 0. All right, so I need f of 0 and f prime of 0. So f of 0 is -1 and f prime is -2. So -1, -2. So I have g prime of 0 minus 1 times 1 minus 2. So it's g prime of -1 times -1. G prime of -1 is 1. So we're going to put that in there. So we get -1 times -1 equals 1. Something went wrong somewhere. So I briefly paused it just to look at it. I think I might have a typo in my answer. I'm kind of thinking that one should be 1. All right, let's keep going. We got a few more here that we had not done yet. So 16, which is very similar to kind of what we've been doing here, except that this one is an inverse this time. So I need to have the derivative of the inverse. Okay, so if I just went and looked up my derivative of my inverse formula, which again, I would write out a sheet of my formulas. I would have this one written down. So it's 1 over f prime of f inverse of x. And sometimes we use an f inverse, sometimes we use a g. So what I actually need to find is f inverse's derivative at 10. So I do 1 over f prime of f inverse of 10. You'll notice that we don't have f inverse of 10. But I remember I switched the x and the y, and that gets me the inverse. So technically, f inverse of 10 is equal to 6 because I swapped the x and the y here. So I have 1 over f prime of 6, and f prime of 6 just happens to be -5, so this one is -1/5. All right, I think this is the last one we have to do. Ooh, let's try that again. Okay, so we need to take the arc cosine of 3x squared minus 1. And if you look at all of your answer choices, they're all very similar. We know the derivative has to start with a negative. We're definitely going to look this up as to what we're doing. And this is very similar to the sine. So it's actually, the generic formula is -1 over the square root of a squared minus u squared. So remember, your a is your denominator and your u is your numerator. But I do have a chain rule going on here, so it's a little bit different. So u equals 3x squared minus 1. So u prime equals 6x. And then when I go to, I'm going to go substitute that into this function here. So I get f of x equals arc cosine of u. So f prime of x equals -1 over the square root of, my a value is going to be 1, my u value is going to be the u. And then remember, I have to multiply by the inside function, so I'm multiplying by 6x. So we get -6x over the square root of 1 minus the u, which is this 3x squared minus 1 squared. So it is looking like answer choice D. And I believe that's the last one that we had to do.